Solving quadratic equations by completing the squares. Our next problem, we have a squared minus 10a equals to negative 7. To solve for the value of a, we need first to identify if this quadratic equation has a numerical coefficient on the first term. Since there is none, we can proceed. So we will have here a squared minus 10a. Now, we will add a third term to make this as a perfect square. So we will add here, the term will be a fraction. The numerator will be the numerical coefficient of the second term, disregarding the sign. So this will be positive 10, and the denominator will be a constant number 2. This term will be raised to the power of 2. And then take note, whatever is added on the right side must also be added on the, or whatever is added on the left side must also be added on the right side. So we also have here plus 10 over 2 divided by 2. A squared minus 10a plus 10 divided by 2 is 5. This will be 5 raised to the power of 2 equals to negative 7 plus 5 raised to the power of 2. We will have here a squared minus 10a plus 5 raised to the power of 2 is 25, and this will be negative 7 plus 5 raised to the power of 2 is 25. A squared minus 10a plus 25 is a perfect square. So the factor here will be a, and since this is negative, we will also have here minus sign, and the square of 25 will be 5. So this quantity here will be raised to the power of 2 since this is a perfect square. And then we have here negative 7 plus 25, this will be positive 18. Okay, so to get rid of the square, we need to get the square root of both sides. So we will have here the square root on the left and the square root on the right. Okay, so we are going to have here the square root of the quantity a minus 5 raised to the power of 2 equals to the square root of 18. Now the square root of a minus 5 raised to the power of 2, that will be equal to a minus 5. So this will be a minus 5 equals to the square root of 18 is plus minus the square root of 18. We can simplify 18, so this will be a minus 5 equals to plus minus the square root of 18. The factors of 18 will be 9 times 2. Okay, now to find for the value of a, we need to transpose negative 5 to the other side. So transpose that to the other side. What will be left? On the left side will only be positive a. This is equal to plus minus the square root of 9 is 3. So this will be plus minus 3 square root of 2. If we transpose negative, this will change sign. So this will now become positive 5. So our a sub 1 here will be the positive 3. So this will be positive, okay? That will be positive 3 square root of 2. So again, our a sub 1 will be 3 square root of 2 plus 5. And our a sub 2 will be the negative 3 square root of 2 plus 5. So we can rearrange this. This will be 5 plus 3 square root of 2, or a sub 2 here will be 5 minus 3 square root of 2. So these are now our final answers. Solving quadratic equations by completing the squares. Next problem, we have positive 2b squared minus 12b equals to negative 14. So since we have here a numerical coefficient, first we need to cancel this out. So to cancel this out, we are going to divide both sides of the equation by 2. Okay, so 2b squared times 1/2, that will be 2b squared divided by 2. So this will be 2b squared all over 2 minus 12b times 1/2, that will be minus 12b all over 2, and this will be equal to negative 14 times 1/2, that will be negative 14 divided by 2. So 2 divided by 2, we can cancel this out. This will be equal to 1. 12 divided by 2, cancel that out, this is equal to 6. And negative 14 divided by 2, this is 7. Okay, so we have here 1 multiplied by b squared. This will give us positive b squared minus 6 times b, that is 6b, equals to negative 7. Okay, we now have no numerical coefficient on the first term. We can now proceed on completing the squares. We have here b squared minus 6b. So in order to complete the square, we are going to add the third term here, and the third term is a fraction. Our numerator will be the numerical coefficient of the second term, disregarding the sign, so this will be 6. Our denominator will be a constant number 2. And then this term or this quantity will be raised to the power of 2. And again, take note, whatever is added on the left must also be added on the right side so as not to change the equation. So this will still be plus 6 all over 2 divided by 2. So we have here b squared minus 6b plus 3 divided by 2, or rather 6 divided by 2 is 3. 3 raised to the power of 2 is 9. So this will be negative plus 9. Okay, so b squared minus 6b plus 9 is a perfect square. So this will be b, and since this is negative, this will also be minus sign, and the square root of 9 is 3. So since this is a perfect square, we are going to raise this quantity into 2. Now, negative 7 plus 9, this will give us positive 2. Okay, so b minus 3 raised to the power of 2 equals 2. To eliminate this exponent, we need to get the square root of both sides. So this will be the square root of b minus 3 raised to the power of 2 equals to the square root of 2. The square root of this quantity b minus 3 raised to power of 2 will now be b minus 3 equals to plus minus. We cannot simplify this anymore, so this will be plus minus square root of 2. Now, to find for b, we need to transfer out transpose negative 3 to the other side. So transposing, what will be left on the left side will now only be positive b, and this will be plus minus square root of 2. If we transpose negative, this will change sign. This will now become positive 3. So our b sub 1 here will be the positive. So this will be the positive square root of 2 plus 3. And our b sub 2 will be the negative. So this will be negative square root of 2 plus 3. We can simplify this b sub 1, or we can rewrite 3 plus square root of 2, And b sub 2 will be positive 3 minus square root of 2. So these are now our final answers. Solving quadratic equations by completing the squares. Our next problem, we have 4b squared minus 8b equals to 32. Okay. So first, we need to cancel out the numerical exponent of our first term. So we need to divide both sides of the equation by 4. Okay. So 4b squared times 1 over 4, that will be 4b squared divided by 4. And negative 8b times 1 over 4, that will be negative 8b all over 4. This will be equal to 32 times 1 over 4, that is 32 divided by 4. So 4 divided by 4, we can cancel this out. This is equal to 1. And 8 divided by 2, this will be equal to positive 2. 32 divided by 4, this is 8. Okay. So 1 multiplied by b squared, this is equal to b squared minus 2 times b, that is 2b, and this will be equal to positive 8. Okay, we can now complete the square. Okay, we have here b squared minus 2b, and then we will add here a third term. Okay, so this will be plus, the third term will be a fraction. The numerator will be the numerical coefficient of our second term, disregarding the sign, so that will be 2. And then the denominator will be the constant number 2. Now we have to raise this to the power of 2. Okay. Now whatever is added on the left side must also be added on the right side. So we have here 8 plus 2 over 2 raised to the power of 2. So we have here b squared minus 2b plus 2 divided by 2 is 1 raised to the power of 2, that still is equal to 1. So this will be 8 plus 1. This is now a perfect square. So let's factor this out. The factor or the square root of b squared is b. Since this is negative, this will also be minus. And the square root of 1 is 1. And then we are going to raise this quantity to the power of 2, since this is a perfect square. And we have here positive 9. Now, to remove this power of 2, we need to get the square root of both sides of the equation. So we will have here the square root of b minus 1. So this will be the square root of b minus 1 raised to the power of 2 equals to, okay, let's check. So this will be equal to 9. Okay, equal to the square root of 9. So the square root of b minus 1 raised to the power of 2, this will now be b minus 1, and this will be plus minus 3. So to solve for b, we need to transpose negative 1 to the other side. So just transpose that to the other side. What will be left on the left side will now only be b, and this will be equal to plus minus 3. If we transpose negative, this will change sign. This will now become positive 1. Okay, so our b sub 1 now will be the positive 3. So this is positive 3 plus 1. Our b sub 2 will be the minus 3. So this is minus 3 plus 1. So b sub 1 here is 3 plus 1. That is 4. And b sub 2 will be negative 3 plus 1, negative 2. These are now our final answers. Solving quadratic equations by completing the squares. Our next problem, we have x squared plus 5x minus 39 all over 4 equals to 0. So to solve this quadratic equation by completing the squares, first we need to make sure that there is no numerical coefficient before our first term. So since there is none, we can proceed. And then next we need to transpose the third term to the right side because we are going to make here a new term. Okay, so transpose this to the right side. Transposing, what will be left on the left side will now only be x squared plus 5x equals 2. If we transpose negative 39 all over 4, this will change its sign. This will become positive. So this will now be positive 39 all over 4. And then we will have here a third term. We are going to add the third term. So adding, we will have plus our third term will be a fraction. So the numerator will be the numerical coefficient of the second term, disregarding the sign. So this will be positive 5 and divided by a constant number 2. And then raise this term to the power of 2. Now take note, whatever is added on the left should also be added on the right side. So we will also have here 5 all over 2 raised to the power of 2. So we have here x squared plus 5x plus 5 raised to the power of 2, that will be 25, and 2 raised to the power of 2 is 4. And we have here 39 all over 4 plus 25 over 4. Okay, now x squared plus 5x plus 25 all over 4 is a perfect square. So we can factor this out and raise the factor to the power of 2. Okay, so factor x squared, so its square root will be x. And since this is positive, this will also be plus, and the factor or the square root of 25 all over 4 will be 5 all over 2. So add the quantity of x plus 5 over 2 raised to the power of 2. This is our perfect square. And then we are going to add the terms on the right. So 4 plus, so since our denominator is the same, we will just copy that and then add the numerators. So 39 all over, so 39 plus 25, this will give us positive 64. So to remove the square sign here, we are going to get the square root of both sides. So this will be the square root, and this will be also the square root on the right. So on the left will be the square root of the quantity of x plus 5 over 2 raised to the power of 2 equals to the square root of 64 all over 4. So that will be 64 all over 4. So the square root of the quantity of x plus 5 over 2 raised to the power of 2 will now be x plus 5 over 2. This will be equal to the square root of 64 all over 4. Okay, so this will be plus minus 8 all over 2. Okay, to find for x, we need to transpose positive 5 over 2 to the other side. So we need to transpose this to the other side. So our x now will be x is equal to plus minus 8 over 2. If we transpose this, it will change sign. So from positive, this will become negative 5 over 2. our x sub 1 will be the plus. Okay, so we have here plus 8 over 2 minus 5 over 2. And our x sub 2 will be equal to the minus, so this will be minus 8 over 2 minus 5 over 2. So since we have the same denominator, we will just, okay, this is x sub 1. X sub 1. Now since we have the same denominator, copy the denominator and then subtract the numerator. So 8 minus 5 is 3, or this would be 1 and 1/2. Our x sub 2 here, copy the denominator, which is 2, and subtract negative 8 minus 5. This will be negative 13, or this will be negative, okay, this will be 6, negative 6 and 1/2. So therefore, x sub 1 equals to positive 1 and 1/2, and x sub 2 equals to negative 6 and 1/2 are our final answers. Solving quadratic equations by completing the squares. Next problem. We have y squared plus 9y plus 45 all over 4 equals to 0. So to solve this quadratic equation by completing the square, first we need to check if there is a numerical coefficient before our first term. So since there is none, we can now proceed. Now, we need to transpose positive 45 all over 4 to the right side so that there will only be 2 terms left on the left side. So we need to transpose that to the right. We will have here y squared plus 9y equals 2. If we transpose positive to the other side, this will change sign. It will become negative. So this will now be negative 45 all over 4. Okay, and then we are going to add here a third term to make it a complete square. So we are going to add, so the third term will be a fraction, and the numerator will be the numerical coefficient of our second term. So this is 9. Divide this by a constant number, and that is positive 2. And raise the term to this power of 2. So we have here y squared plus 9y plus 9 raised to the power of 2, that will be 81, and 2 raised to the power of 2 is 4. Whatever is added on the left side must also be added on the right side. So this will be plus 9 over 2 squared. So negative 5 over 4 plus 81 all over 4. So y squared plus 9y plus 81 over 4 is a perfect square. So we can have this, okay, so the factor of y squared, or the square root of y squared, is y. And then since this is positive, this will also be plus, and the square root of 81 all over 4 will be 9 all over 2. And then you raise this term to the power of 2. And this will be equal to, now since they have the same denominator, just copy the denominator, and then negative 45 plus 81. Okay, so negative 45 plus 81, this will give us positive 36. So this will be positive 36 all over 4. Now to remove the square sign here, we need to get the square root of both sides of the equation. So we will have here the square root of and the square root of. Okay, so on the left side we will have the square root of the quantity of y plus 9 over 2 raised to the power of 2. And we will have here the square root of 36 all over 4. Okay. So the square root now of the quantity of y plus 9 over 2 raised to the power of 2, this will be equal to y plus, okay, let's check. That's y plus 9 over 2. And this will be equal to the square root of 36 over 4. This will be plus minus 6 all over 2. So to solve for y now, we need to transpose positive 9 over 2 to the other side. So we need to transpose this to the other side. What will be left on the left side will now be y equals 2 plus minus 6 all over 2. If we transpose plus minus 9 over 2, or rather plus 9 over 2, this will change sign. This will now become negative 9 over 2. So our y sub 1 here will be plus 6 over 2 minus 9 over 2. Our y sub 2 will be the minus 6 over 2 minus 9 over 2. So our y sub 1 will be, copy the denominator, which is 2, 6 minus 9, that is negative 3. And this will also be negative 1 and 1/2. Our y sub 2 will be, copy the denominator, which is 2, and then negative 6 minus 9, this will be negative 15 over 2, or negative 7 and 1 over 2. So therefore, y sub 1 equals to negative 1 and 1 over 2, and y sub 2 equals to negative 7 and 1 over 2. They are our final answers.